For this question, we've been asked to look at a student's attempt to answer this question. So I'm going to start by answering the question, and then we'll go and answer part A and part B. So we have 2 to the power of 2x plus 4 minus 9 multiplied by 2 to the power of x is equal to 0. As a student, you need to be able to recognize that this is a hidden quadratic, where I'm going to be trying to look at this term here and rewrite everything in terms of 2 to the power of x. So I'm going to start off by saying y is equal to 2 to the power of x. So I'm looking at this term here, and that's what you should try and do. Normally, if you've got a quadratic in the form of ax squared plus bx plus c, and that's equal to 0, this value here, okay, that's what you're going to try and use to think about. If I've got this squared, I have a quadratic. In this particular question, there's no c, there's no constant term, so you just got ax squared plus bx, where I'm going to try and rewrite this term as ax squared, where I've taken my x, or in this case capital Y, to be equal to 2 to the power of x. So you should be able to notice that before you try and attempt the question. So I've got 2 to the power of x here, that's fine. The question is basically testing whether you can actually deal with this term and rewrite it in the form of 2 to the power of x. So let's deal with this now. I'm going to use a different color pen. I've got 2 to the power of 2x plus 4, and I can now rewrite this as 2 to the power of 2x multiplied by 2 to the power of 4. Why? Because of rules of indices. So I've got a to the power of x plus y in the power, in the exponent, and that's the same as a to the power of x times by a to the power of y. You should know that from GCSE, and you've probably learned it since year 9. So that's my first step. And then my second step is to think about, okay, how can I rewrite this in terms of 2 to the power of x? So 2 to the power of x, if I put brackets all the way around and square, that will give me 2 to the power of 2x. And all I'm doing there is I'm taking advantage of this indices rule, which you should be familiar with, x times y. So now I've managed to get my 2 to the power of x, and I can just simplify this. That's 2 to the power of 4, which is 16. 2 times 2 times 2 times 2. And I have now been able to rewrite this term here in my question as, I'm going to write the number in front, 16 lots of 2 to the power of x all squared. So let's go back to the question. This bit is the same as 16 lots of 2 to the power of x all squared minus 9 2 to the power of x is equal to 0. And what I can do here is I can say, okay, let capital Y, it doesn't matter what letter you use, but I think this definitely helps to understand what's happening. Let capital Y equal 2 to the power of x. I'm going to substitute every term which has 2 to the power of x with capital Y. So that's 16 y squared minus 9 y is equal to 0. And hopefully this is more familiar to you, and you should be able to handle this. If I'm trying to solve this equation, this is still a quadratic, but like I said, it hasn't got a constant term. The constant term is 0. So you should be thinking of, what are the common factors? I've got a common factor of y, so I can factorize, take out the y and put brackets in. So 16y squared divided by y is 16y. I can check if that's correct. Y times 16y is indeed 16y squared. And then minus 9y, don't forget the sign in front of the term, minus 9y divided by y is minus 9. I can check that as well. Y times minus 9 is minus 9y, that's correct, equal to 0. So now I'm at a stage where I'm going to take advantage of something that you should inherently understand. A times b is equal to 0. Therefore, either a is equal to 0 or b is equal to 0. And that is something that I think many students just do not really fully appreciate. Just go straight into this step, y equals 0 or 16y minus 9 equals 0. And the reason behind that is what I've just explained here, which you should really understand. So from this step, I can say that 16y is equal to 9, and therefore y is equal to 9 over 16. But as I'm sure you will appreciate, I did make capital Y equal 2 to the power of x. So let me come to this side here, y equals 0 or y equals 9 over 16. So let y become 2 to the power of x, which is equal to 0, or 2 to the power of x is equal to 9 over 16. Hopefully you appreciate that an exponential function, if I'm trying to make 2 to the power of x equals 0 and figure out what value of x gives me the value 0, you should all really appreciate straight away that there's no solution here, and you should be able to understand why. If you don't understand why, here's the graph of 2 to the power of x. Okay, if I zoom out, zoom out, zoom out, zoom out, zoom out, zoom out, you can see that it never crosses the line y equals 0, which is the x-axis. On this side, the same graph, 2 to the power of x, I want to see what value of x gives me the value of 9 over 16. So I can actually draw the graph of 9 over 16 and see visually what's actually happening here. So let's build this up. There's the graph of y equals 0, which I just mentioned. There's no solution there. And there's the graph of y equals 9 over 16. So you can see there is a solution. And if I just click on this point, I'll be able to have an idea what the numerical solution is for the value of x. And the numerical solution is indeed that value there. Okay, so there is a solution. And that's the value. In order for me to answer the question, part B, find the exact solution to the equation. The reason why they've mentioned the word exact here is because as you can see, this solution, it just goes on. That's been rounded. So this value of x has been rounded. It just goes on and on forever. So how would I answer this question? You would do it by using logs. I'm going to use a different color pen here just to highlight that I'm using logs. And some of you might not be confident with logs yet, but I'm just going to show you how we'll do this. Take logs on both sides. So log 2 to the power of x equals log 9 over 16. Okay, if I haven't put a base, that means that I'm using base, but it doesn't matter what base you use. You could use lin as well, so it doesn't really matter, and I'll explain and show you that later using GeoGebra. So using log rules, I'm bringing this exponent down using the power rule. So that's log 2 to the power of x is the same as x log 2, and then I've got log 9 over 16 here. Okay, and then my x, the exact value for x using logs is log 9 over 16 all divided by log 2, and that will give you 4 marks for part B. Just to explain visually what's happening, so this is definitely my solution. Okay, that blue line represents y equals 9 over 16, that one there. So I want to work out what's the x value. So what's this value? Minus 0.8307. So if you type this in a calculator, it should give you this x value there. So if I show you, that is basically the answer with the base 10. There you are. You can see it cuts that point exactly where we want it to. If I change the base to e, where I would actually have lin, you can see it doesn't actually make any difference which one you use. It still gives me exactly the same answer. So that's visually what's happening. And if you've got the word exact, that means that you would need to leave the answer in terms of logs, because if you type this in a calculator, it's going to give you that value there. Part A, so just to get the marks for part A, where are the mistakes? So I can see straight away that one mistake is there, line 2, going from line 1 to line 2, 2 to the power of 2x plus 4 is not the same as 2 to the power of 2x plus 2 to the power of 4. It's actually 2 to the power of 2x times by 2 to the power of 4. So that's mistake 1. And mistake 2, that's pretty easy if you think about it. 2 to the power of 4 is 16. You can see that there. And they've written 8. Hopefully you found this useful. Please make sure that you revise laws of indices, exponential functions, and being able to recognize hidden quadratics. Those are the main topics for this question.